Hello, and welcome to How It's Made, the channel where we demystify manufacturing processes behind products you use every day. Today, we're diving deep into the fascinating world of bearings. These unsung heroes are crucial components in countless machines, from your car's wheels to massive industrial turbines. But have you ever wondered how these precision parts are actually made? How are bearings produced? And what are the intricate steps involved in their creation? Join us as we uncover the secrets. Our journey begins with the selection of raw materials. Bearings are typically made from high-carbon chromium steel, known for its exceptional hardness and wear resistance. This steel arrives at the factory in the form of long bars or tubes. The quality of these raw materials is paramount, as it directly impacts the performance and lifespan of the final bearing. The first major step is cutting. The steel bars or tubes are cut into precise lengths, often using high-speed saws or automated shearing machines. This initial cut determines the basic size of the bearing components. Accuracy here is critical to minimize waste and ensure consistency in subsequent processes. Next, we move to forging or pressing. For larger bearings, cut pieces might be heated and then forged into a rough shape, which helps to align the grain structure of the steel, enhancing its strength. For smaller bearings, cold pressing might be used. This process forms the basic rings of the bearing, the inner and outer rings. After forging or pressing, the components undergo annealing. This heat treatment process softens the steel, making it easier to machine and relieving internal stresses that might have built up during the previous steps. Annealing is crucial for preventing cracks and ensuring uniform hardness later on. Now comes the machining phase. This is where rough shapes are transformed into precise bearing components. Lathes, grinders, and other specialized machines are used to turn, bore, and face the inner and outer rings to exact dimensions. The raceways, where the rolling elements will run, are also precisely machined at this stage. This requires incredibly tight tolerances, often measured in micrometers. Once the rings are machined, they proceed to heat treatment. This is a critical step that gives the steel its characteristic hardness. The components are heated to very high temperatures, then rapidly quenched in oil or water, and finally tempered. This process transforms the steel's microstructure, making it extremely hard and durable, capable of withstanding immense loads and friction. Following heat treatment, the components undergo grinding and superfinishing. Even after machining, surfaces are not smooth enough. Precision grinding machines remove tiny amounts of material to achieve the required dimensional accuracy and surface finish. Superfinishing or honing further refines the raceway surfaces to an incredibly smooth, mirror-like finish. This smoothness is vital for reducing friction, noise, and extending the bearing's life. While the rings are being processed, the rolling elements, balls or rollers, are also being manufactured. These are typically made from similar high-quality steel. For balls, wire is cut, then cold-headed into spheres, followed by grinding, lapping, and polishing to achieve perfect sphericity and surface finish. Rollers undergo similar precision machining and grinding processes. The cage or retainer is another essential component. It keeps the rolling elements separated and properly spaced. Cages can be made from pressed steel, brass, or various polymers. They are typically stamped, machined, or molded to their final shape. Finally, all the meticulously crafted components come together in the assembly stage. The inner ring, outer ring, rolling elements, and cage are carefully assembled. This is often done in cleanroom environments to prevent contamination. Automated assembly lines ensure speed and precision. After assembly, each bearing undergoes rigorous inspection and testing. This includes dimensional checks, noise and vibration testing, and sometimes even endurance testing. Only bearings that meet the highest quality standards are approved. The final steps involve lubrication and packaging. Bearings are often pre-lubricated with grease or oil. Depending on their application, they are then carefully packaged to protect them from corrosion and damage during storage and transportation. And there you have it, the incredible journey of a bearing from a raw steel bar to a high-precision component. Ready to keep the world turning? The complexity and precision involved in each step highlight the ingenuity of modern manufacturing. We hope you enjoyed this deep dive into how it's done. Don't forget to like, share, and subscribe for more fascinating insights.